Okay, next section in the unit, 2.2, day 1, analyze conditional statements. So first, what is a conditional statement? If P, then Q. So whatever P is, if P happens, then Q will be true, is basically what we're saying, or then Q will happen. The negation is opposite of the original statement. So if, say, our first statement was, if I ride a roller coaster, then I get sick. The opposite of that is, if I don't ride a roller coaster, then I do not get sick. So that is the negation. Negation is just opposite of that if-then. And don't get that confused with converse. Converse is if Q, then P. So we just switched the hypothesis and conclusion. So notice conditional statement is if P, then Q. If P, then Q. But then the converse is if Q, then P. So sometimes the conditional is true and the converse is false. Sometimes the converse is false or is true and the conditional is false. Or sometimes it can be switched. Sometimes they can both be true. Sometimes they're both false. And we'll talk more about that later. But conditional statement, if P, then Q. Negation is opposite of the original statement. And converse is switching the hypothesis and conclusion, so making it if Q, then P. So in this example, we're told, looking at the top, if it is raining, all right, that's my hypothesis. That's my P statement. And if this is my conditional statement, if it is raining is P. That'll be P. Then there are clouds in the sky. So my conclusion is that there will be clouds in the sky. And that is Q. So if it is raining, then there are clouds in the sky. And notice if and then aren't included as part of P and Q. They're just helping us separate the two. So example number 1, we need to rewrite the statement in if-then form. So here's our first statement. All birds have feathers. So our birds are our P, and feathers are the Q. So how could we write all birds have feathers in an if-then statement? We know P goes with if, so if the animal is a bird, comma, then it will have feathers. If the animal is a bird, then it will have feathers. So we're able to turn that statement, all birds have feathers, into an if-then statement. So that is our conditional. So then let's look at the second one. Two angles are supplementary if they are a linear pair. So we need to look at our statement identify what our hypothesis is and what the conclusion is. So actually we have if right here in the middle. So that tells me that actually this last part, they are a linear pair, is my hypothesis, if they are a linear pair. That's my if of the if-then statement. So then two angles are supplementary is going to be Q. So the if-then statement doesn't always have to be written with the if first. So we're going to have to switch these around. So to write it like this, we would say if the two angles are a linear pair, then they are supplementary. Then they are supplementary. So notice we had to reword our conditional statements to get them into if-then form. So make sure you're not just putting an if and a then right in front of whatever the hypothesis and conclusion are. You're probably going to have to reword them to make them so that they make a little bit more sense, or that they sound a little bit better. Because if we did that on letter A, we said if birds, then feathers. That doesn't really, we need some more information in there. If the animal is a bird, then it will have feathers. So make sure you're rewording to make it sound a little bit better. But you still need to have those same information that is P going along with the if statement and our conclusion, which is Q, going along with the then statement. All right, some more examples. So in this one, we need to rewrite the conditional statement in if-then form. So here, number one says all 90-degree angles are right angles. So this first part is the P. The second part is the Q. And we can say that if the angle measures 90 degrees, then it is a right angle. If the angle measures 90 degrees, then it is a right angle. You won't have to get all of the words exactly the same as I write them when you're coming up with your own, but it needs to say basically the same thing. So we know all 90-degree angles are right angles, so if we measure an angle and it's 90 degrees, then it is going to be a right angle. All right, looking at number 2. 2x plus 7 equals 1 because x equals -3. So our 2x plus 7 equals 1 is our hypothesis. And the conclusion is x equals -3. So we would say if 2x plus 7 equals 1, then x equals -3. That would be our if-then statement for that. Okay, example number 2. Is the conditional statement true or false? If false, we need to give a counterexample. So, if you live in Missouri, then you live in Lee Summit. Is that true or false? That would be false. What would be a counterexample of that? You could live in Blue Springs. I live in Blue Springs. I still live in Missouri. So Blue Springs would be my counterexample. But somebody could live in Blue Springs. Number 2, if n equals 3, then 2n minus 2 equals 4. So to see if this is true, we need to plug in 3 for n and see if we get 4. So if we plug in 3, 2 times 3 is 6, minus 2 is 4. So that is true. And then another way to write conditionals. So if the conditional statement is, if your birthday is in the summer, then it is in July. Is that true or false? That would be false. And then a counterexample to that, June. You could have your birthday in June and it'd still be in the summer. So then, if P, then Q, what is our P here? So P equals what? Your birthday is in the summer would be my hypothesis. And then the conclusion is, it is in July. It is in July. So this other way that we can write these conditionals is with a converse. Remember, that's switching our hypothesis and conclusion. It's switching the P and the Q. So the converse of this statement is, now we're going to have our Q first in the if part of the statement. If your birthday is in July, then it is in the summer. Is that statement true? If your birthday is in July, then it is in the summer. Yeah. That time, on this one, when we switch it to the converse, we switch our hypothesis and conclusion, the statement became true. Okay, so let's look at our next example. We need to write the if-then form and the converse of the following conditional statements. So our first statement, A, guitar players are musicians. So we need to decide whether each statement is true or false. Guitar players are musicians. So first we're going to write it in the if-then form and tell whether it's true, and then write the converse in the if-then form and tell whether it's true or false. So guitar players, that's the P, are musicians is the Q. So how can we write this in if-then form? Think about that for a moment and see if you come up with something similar to what I write. So if you are a guitar player, then you are a musician. And is that true or false? If you're a guitar player, are you a musician? Yes, that's true. Now we need to write the converse of that. And remember, converse is switching your hypothesis and conclusion. Our hypothesis was if you are a guitar player, and the conclusion was then you are a musician. We need to switch those in our if-then statement. So now we're going to say if you are a musician, then you are a guitar player. If you are a musician, then you are a guitar player. Is that true or false? Can you be a musician and play something other than the guitar? Yeah, so that is false. If you are a musician, then you are a guitar player. False. All right, and then the last example, we need to write the converse and tell whether it is true or false. So our conditional statement is, if a polygon is equilateral, then the polygon is regular. We're going to write the converse and then tell whether it is true or false. So if a polygon is equilateral, is the P. The polygon is regular, is the Q. Try and write this converse statement. So go ahead and pause, write your converse statement, and then pause and see if we come up with the same thing. Okay, so since polygon is equilateral is our hypothesis, and the polygon is regular is the conclusion, we're going to switch those in our if-then statement. So we'll say if the polygon is regular, then the polygon is equilateral. If the polygon is regular, then the polygon is equilateral. Is that true? Yes, it is. We know all regular polygons are both equilateral and equiangular. So if the polygon is regular, then the polygon is equilateral. That is true. All right, that's it for the notes on 2.2 day 1. Have a great day.